So welcome everyone. Today we are going to look at chemical bonding. So in this presentation, we are going to see what chemical bonds are. What are chemical bonds made up of? And why do atoms or even elements form what we call chemical bonds? And then we'll look at the different types of chemical bonds. We'll just mention them, and then after that, we'll have separate lessons looking at each of these bonds that we are going to mention here. So we know what compounds are. Compounds are when you have elements combining through chemical bonds with fixed ratios. So let us say we have water being formed. So the water is a simple molecular compound that has hydrogen and oxygen. Okay, just like what you see here, oxygen and hydrogen. So oxygen is a separate element, and then also hydrogen separate element. So they are connected through what we call bonds. These are bonds. Okay, and we emphasize that compounds compounds combine at fixed ratios. This is to say that for every molecule of water, we have two hydrogen atoms. This one and then this one. But we only have one. So we have a ratio of 2 to 1. So oxygen 1, hydrogen 2 there. Okay, so our discussion is on the bonds that are formed between these atoms to form this compound. But we can also have an element that exists as a diatomic molecule. So, for example, oxygen. We write oxygen like with this O and then a subscript 2, meaning that we have oxygen being bonded to another oxygen atom. So we have two atoms existing in molecular oxygen. Okay, so these are the bonds in between there. So when we talk about bonds, we are not only talking about the connection that we have for atoms that we have in a particular compound, but we can also talk about atoms that exist as either triatomic, diatomic, or whatever it is. So we can have atoms within the same element. So these atoms are actually bonded. Okay, we are connected to one another. Okay, so we use dashes to represent the bond. Okay, so if there are two, then we put two dashes. That is to say two bonds. Okay, the bonds are what are patches, or is what forms a strong attraction between two atoms. Okay, all right. So we move, still emphasizing that the bonds are the ones that hold these atoms together. Okay, so here we have fluorine. One atom of fluorine here, and then another atom of fluorine there. Okay, so this here, we shall basically see, or maybe we can note at this point here, that this bond, the chemical bonds, are formed when either electrons are shared. So bonds are basically about electrons that are either donated or shared. Okay, so the aim of formation of these bonds, the question could be, why do these atoms actually form bonds? Okay, why do they form bonds? Can they exist on their own? Then The issue to do with bond formation is the fact that we want, or the atoms want to attain what we call a stable configuration. Okay, and that stable configuration is when they have what we call a noble gas configuration, where at least you should have 8 electrons in the outermost shell, or at least you have 2, like for helium. Okay, helium and the other noble gases have what we call stable gas, noble gas configuration. Okay, and that is what all other atoms want to achieve. But of course, there are exceptions to that you look at maybe in your study of the different elements of the periodic table. You realize that some elements don't obey the fact that they need to have at least 2 or 8 electrons in the outermost shell. And you look at that especially in organic chemistry. Okay, so atoms bond together such that they attain the noble gas configuration, which is termed as the stable configuration. Okay, and this can be done by either sharing electrons or by transferring electrons. So that is what happens, and we shall look at the issues to do with whether sharing or transferring, giving us the different types of bonds that we have. Okay, so the other point that I want to stress here, what we see here as the octet rule, and then duplet rule. These are all stable configuration. One is for helium, and then the other is for the other noble gases. All atoms want to attain that. Okay, so that's why they form bonds, and the bonds are basically issues to do with electrons either being shared or being donated or transferred. For example, we have argon here. So how many electrons do you have in the outermost shell for argon? We have these 2 here, and then we have these 2 here. Those are 4. And then we have these 2 here. Those are 6. And then we have these 2 here. Those are 8. So that is a stable configuration like that of noble gases. And this is basically noble gas argon. So the octet rule is that atoms want to attain, want to have, or want to achieve, or want to attain the noble gas configuration. And that is according to the octet rule. However, there are some elements that do not conform to this rule. Okay, and especially elements of period 3 and beyond. One of the exceptions that we can talk about is for phosphorus pentachloride. Phosphorus pentachloride is actually stable, but when you look at the number of electrons that are available for bonding to form what we call the phosphorus chlorine bonds, which are actually 5, in like what you see here. Those are 5 bonds, and that means that in phosphorus pentachloride you have 10 electrons that are used for bonding, and this actually exceeds the usual octet rule that we have been talking about. And this is basically because phosphorus has a large atomic size, and this allows it to accommodate more electrons. Okay, so when, for example, you would expect to have phosphorus trichloride, this is actually unstable, and that is why we have this instead, and it is unusual, and that's why we are calling it an exception, because it does not obey the octet rule. But there are other examples that you can look at, whether to do with boron or beryllium, and the unusual compounds that they can form because of their inability to basically disobey the octet rule. I want to introduce a concept to do with Lewis structures, Here, for example, we are showing how chlorine exists. Because chlorine is a diatomic molecule. That means you have a chlorine existing with two atoms. So how is that bond made between the two chlorine atoms? We can basically illustrate or visualize the nature of bonds and the electrons involved using what we call the Lewis structures. So the Lewis structures help us to visualize how the bonds are formed. Then we use dots to represent the electrons that are involved. So, for example, the electrons from this first chlorine atom are represented by these dots, and then these X's are representing the electrons from the other atom. And therefore, the bond that we are having in here is represented by having one electron being contributed by each of the atoms. Okay, so this kind of structure where you have the dots representing electrons is what we call Lewis structures, and they help us to represent the different bonds in atoms of a molecule. Okay, you can also as well see that electrons exist in pairs. Okay, what we call lone pairs of electrons. That means that actually these electrons can be involved in different reactions. So in here, you can see the electrons that are available. Group 1, you can say that there's always one dot. Group 2, 2 dots, and then more dots this side. Of course, 8 dots for the other noble gases, and only 2 electrons for helium there. And then 7 for group 7, and then the rest. So that is about the Lewis structures. So the last thing that we are looking at here are the types of bonds. Like we have said, these different types of bonds illustrate whether electrons have been shared or electrons have been transferred, or electrons have been accepted or electrons have been donated. And basically it's about electrons. How are they behaving in different types of bonds? So we shall talk about ionic bonds. We shall talk about covalent bonds. We shall talk about dative bonds or coordinate bonds, metallic bonds. We shall also talk about van der Waals forces and then hydrogen bonding. So those are going to be our subsequent lessons after this. So bonds are very important, and that they enable atoms to attain the stable configuration like that of noble gases, and that's why bonds are formed. The strength of the bonds influence whether the molecules have high melting point or boiling point or even low. Okay, so we'll look at the strength of each of these bonds and the nature of interactions that these bonds actually have in regards to how electrons actually behave in these bonds. Thank you.